Hello, today we're going to be talking about 6-7 inverse relations and functions. If you take a moment right now, press pause and check your warm-up solutions. For g of f of x, I got x squared minus 1. For g of f of negative 2, I got 3. So you can check yours with mine and then make any corrections that you might need to do. For now, we're going to go through our inverse functions information here. F and g are inverses of each other provided that f of g of x equals x and g of f of x also equals x. That means that when I plug these into each other, my result is an x. G is denoted as f inverse. F inverse. It's not f to the negative 1, just f inverse. And here's things that you need to know, that the domain of the inverse is the range of the original relation, and the range of the inverse is the domain of the original. Basically, it means that you're going to switch the x and the y. You can switch the x's and the y's in order to find the inverses of each other. Let's see how that works. For example, if I have f of x is equal to negative 3x plus 6, let's use this function to do the following. Number 1, find its inverse g. So first thing I want to do, just to help me out, is I'm going to change this f of x to a y. So y equals negative 3x plus 6. Now, in order to find the inverse, because the domains switch, I'm going to switch them. X equals negative 3y plus 6. From here, I'm going to solve for y. And I have x minus 6 is equal to negative 3y. Divide by negative 3. And I have y is equal to x minus 6 over negative 3. The only thing now is they said to find its inverse, g. So I'm going to say g of x is equal to x minus 6 over negative 3. You can also say negative 1/3 x plus 2 if you wanted to simplify that a little bit more, but I'm not finding it too super duper necessary. But just to show you, this is it in simplified form, excuse me. Now, the next thing that they're asking us to do is now we'd like to verify. So in order to verify it, we're going to find f of g of x. So my f of x, the original one, was negative 3x plus 6. My g of x is negative 1/3 x plus 2. Okay, so my verification, I'm going to find f of g of x. So I'm going to start with f of x, which is here. And I have negative 3x plus 6. Now, instead of x, I'm plugging in g of x, this whole function right here. So negative 1/3 x plus 2. Now, if I'm right, and I kind of think I am, this should equal x. Let's check. I'll distribute. Negative 1/3 times negative 3 is just x. Negative 3 times 2 minus 6 plus 6, that does equal x. So that's my first check mark. And then I also need to verify it the other way. So I'm going to plug in g of f of x, which means I'm going to rewrite this function, except now instead of x, I'm going to put f of x, negative 3x plus 6. I'll go ahead and distribute. Negative 1/3 times negative 3 is x. Negative 1/3 times 6, negative 2 plus 2. Lo and behold, it equals x. We have verified. Okay. Next example. Use this function now to do the following. Find its inverse g. And then they're going to ask us, is g of x a function or not? So first steps. I'm going to go ahead and replace that and make this be y equals, oh, just kidding, I'm skipping stuff. Find the inverse of f of x equals x to the 5th minus 2. So y equals x to the 5th minus 2. and then switch. X equals y to the fifth minus 2. First thing, switch your x and y. Second thing, solve for y. And that's how you get your inverse. I'll add 2. X plus 2 equals y to the fifth. To get rid of this fifth, I'm going to take the fifth root and the fifth root. So y equals the fifth root of x plus 2, also known as g of x. And there you go. Okay, extra example here. Do me a favor, try this one on your own. Go ahead, press pause right now. Try it on your own, legit. Press pause. And then when you unpause, you can check your work with my work. Okay, so go ahead and check yours with mine. If not, go ahead and press pause for a moment. I did add 4 to both sides divided by 2, and then I took the square root of both sides. Because I took the square root of both sides, I put a positive and negative outside of there. So once you've verified and make sure that you match me, you're going to do 2 things for me. Number 1, you're going to find f of g of x, and then you're going to find g of f of x. They both need to equal x when you do that. So take a pause right now and then verify using the same methods that we just did right there. Okay, for me it checked out pretty well. Plugged in f of g of x, and so instead of x squared, I wrote this function right here, simplified, 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 and I got x. And then instead of g of x, I plugged in the x for the x right here, so I plugged in this function, the original function, and simplified. Negative 4 plus 4 was just 2x squared up top divided by 2. X equals, I'm sorry, we get x, positive and minus x, but it's still x is verified. Very good. Okay, part A. Use these points in order to do the following. So step 1, find the inverse. So to find the inverse, remember, you're going to switch the x and y. So this first one was negative 1, 3. Now it's 3, negative 1. The next one was 1, 0, 0, 1. So now it's 1, 0. So you're switching them, and you're switching them. And the next one, negative 1, 1. And 5, negative 4. Okay, check. Next thing that they would like for us to do is to plot the original points using pencil. So here's a pencil, the original ones, negative 1, 1, 2, 3, 0, 1, 1, negative 1, and then 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, be bold. Trust me on this one. You want to be really, really bold. In fact, I'm going to be so bold. I'm going to go ahead and go over this in black ink to make sure that they show up. There's a purpose for this. Trust me. And then plot the other points, so my inverse ones, using a different color. So positive 1, 2, 3, negative 1, 1, 0, negative 1, 1, and then 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, this is where I'm going to get a little bit Martha Stewart here. This equation, so fold your paper along the y equals x. So this is y equals x. And so what you should do here is take your paper, lift it up, and fold it. Okay, don't feel weird for this. But right now you kind of can't see. What I'm going to have you do is hold this up to the light, and when you do, if you fold this up to the light, you can't see it on mine because it's a little bit not going to work out for you that way. What you're going to find is that every pink dot, wrong finger, is exactly where the black dots were as well. Every pink dot is exactly where the dark one is. And what that is telling us is that the graph of an inverse relation is a reflection of the original relation. The line of reflection is y equals x. Okay, I'm going to show you how that works using this next part. So the horizontal line test, we know the vertical line test, which says that if this is my function, then any vertical line can only pass through it once. So right now, this passes. This is a function. The horizontal line test, though, so this is for the function f. But for its inverse, which I'm going to call g of x, or f inverse, well, does it pass the horizontal line test? Because remember, everything switches. Sorry about that. So instead of checking to see if it passes the horizontal line test, well, its inverse would need to pass the vertical line, the horizontal line test. This fails. Fail, fail, because it would hit it twice. So I'm going to say that the inverse is not a function. Let's be clear. Original one is a function because it passes the vertical line test. Its inverse fails the horizontal line test, so no, because right there, for example, fail. Here's how you can make sure. Let's pick some points that are on here. So if you look at this, I'm just going to label a couple, 2, 3 points. So these are the points that I'm picking that are on this. It's a parabola, so that wasn't too hard. So its inverse would go through 0, 0, plot. It would go through 1, 1, which is the same that goes through here. And then it would go 1, negative 1. And then it would go 4, 2, and 4, negative 2. So 1, 2, 3, 4, 2, and 4, negative 2. This is what the inverse would look like. Now, does it pass the vertical line test? No, but we knew that from the other function. But if you needed to, this is how you would get the inverse. Okay, try this one. First of all, does it pass the vertical line test? So far, yes. But would its function, f prime, I'm sorry, f inverse, does that pass? No. Nope. So, you can take 1 minute if you'd like to, and I'm going to challenge you. Pick a good couple points. So we see it goes through 0, 0. That's one of them. That's a given. Pick a couple on this side and a couple on this point side. Reflect them. I'm sorry. Switch them. Find its inverse, and then plot them. See what this one looks like as its inverse. Okay, so those are my points, and so to draw that, I'm going to go in there, and I'm going to hook around there. Hold on a minute. Sorry, this did pass their original vertical line test. So this is a yes, that is a function. Now I can verify it and see it because the vertical line test, this one passes. Sorry about that. That was not flat. I thought it was. It's not flat. Okay, so this is a check mark there. For this next problem, graph the relation and its inverse. So the first thing I want to do is just try to flash you back a little bit. To graph this one, this is in vertex form. So my vertex is -4, -4. And then I make an XY table. So -1, 2, 3, 4, 1, 2, 3, 4. That's kind of a bummer. I'm going to go by 2's instead. So 2, 4, 2, 4. This is -4, -4. And then you pick 2 points. So I'm probably going to pick -2 and 0. And then you'll plug those in. Right, and press pause if you need some time to plug in these points. I chose -2 and 0. And then I plotted them. And then I will reflect them. And then that's my original one. Next thing that you're going to do is reflect. So my vertex is still here because it's -4, -4. And then for my XY table, I have 0, -2, and 12, 0. And I'm still going by 2's on the graph. So I reflected them and I plotted them. And this would be my graph. There you go. You can check my work if you'd like to. And that is 6.7. Thank you so much.